Non-destructive inspections of technical parts use various physical methods. Well known are ultrasonic testing and X-ray testing, because they are also used in medical examinations. If non-destructive testing of parts made from plastic and other non-conducting material is necessary, then microwave testing often is appropriate. If you want to learn more on the basics of microwave testing, then you are in the right place. I am Johann Hinken. I welcome you to the channel Microwave Testing. These videos address laypersons and specialists on other fields. In the first series of videos, we will show the technical basics of microwave testing and applications of a handheld test instrument. This instrument can, for example, be used to test parts of glass fiber reinforced plastic, GRP. For example, leaf springs for automobiles, or bends and transitions of GRP pipes. To get attuned, let's directly look to the microwave testing of this section of a GRP leaf spring. Here we see the leaf spring with the display in the background. Now we place the microwave test head on the leaf spring, and we see a small dot in the upper part of the display. This gives the signal of the test head. Now we move the test head slowly along a line over the leaf spring. Here we have an indication, and it's going back. Now it's rather quiet. All quiet, but there are some spirals and a big indication, and some spirals again, and it's quiet again. We can also continuously display and store the indications, as we can see here. Both indications are similar, but without spirals at their roots, right-hand side, and with spirals at their roots, left-hand side. Those of you who are familiar with non-destructive eddy current testing may have noticed the similarities of the shape of the indications. We are talking here about non-destructive testing, that is, inspection of technical parts for defects, especially also for those defects which are below the part's surface and cannot be seen visually. In such cases, we have to learn how to evaluate the findings from outside to characterize the defects inside the parts. So let's get back to our two indications. From what and where do they originate? The first indication is obvious. It is just this shallow, small dent into the surface. The second origin, however, is not such obvious. There is nothing special to be seen here on the surface. Only when we turn the part around, we can see there is a small hole on the backside. And that's the reason for this second indication. The first indications is without the spirals at the root. And the second one is with spirals at the root. So we have already learned that indications without spirals at the root originate from defects near to the surface, and indications with such spirals at the root originate from defects in deeper layers. In the course of the next videos, we will learn how to deduce further defect properties from their indications. Some remarks in advance. Microwave testing uses electromagnetic waves of low power and frequencies quite similar to mobile phones and car distance warning radars. Like these, microwave testing is harmless to people. So far for today, until next time. Meanwhile, for more on microwave testing, you may have a look at www.fitm.de. Goodbye.